Okay, what I want to do in this video is produce multiple JSON messages into a Kafka topic. So in the previous producer example, I showed how to insert one message, and here I'm going to insert at least two messages. We might do more as time goes on. And I want to change the name of this. But before I do that, let's go through the usual things. So these are the imports. I don't think I showed that in the previous video, so it might help to see these import statements right here. And then this one I want to call something like Kafka producer multiple messages. Something like that I think will work for what we're doing. Let me save that. I also have this running. I could show you what I have running here. I did the tilde compile because in the previous video I had some compilation problems, so it's running the compiler continuously on the code over here. So that's that. And what I was about to do was take that and copy that, and I want to put that in the build file over here. So we can do that. And now I want to produce multiple messages. Let me save that. I need to come back here and kill that. I need to reload that because I changed the build.sbt file, as you saw in the messages there, then go back to compile. And now if you saw the previous video, most of this is going to be the same. So we have the Kafka and Confluent configuration properties up here at the top. So this is the topic that we're going into. That's quotes JSON. And that is this one right here over on the Confluent website. This is our topic right there. Come back here. That's the topic. That's the servers. These are the producer settings. And I covered all of that in the previous videos. Let's see, what else do we have? This time I have a case class for the messages. And remember that our messages have a quote and then an author. So if we come back over here, we have a quote. Let me show that here. We have a quote here and then the author right there. That's part of the value. And then the key has an ID and an ID right there. So now if we come back here, for the message part or the value part, we have a quote, which is a string, and an author, which is a string. Then we have the quote encoder, which uses the same JSON technique that I showed in the previous video. And this time I'm only doing that for the quote message. So we have this encoder here. Then what I'm doing is creating a list of quote messages right here. So this first one, in enlightenment, death has no relevance to one state of being. That's a pretty powerful statement right there. There's the author right there. And then in real meditation, you forget the body by Swami Vivekananda. So we have two quote messages in that list right there. Then what I did was we have a function now. So before I had this type of code, this producer code inside of this area right here. And what I did, because we're going to be calling that multiple times now, is I extracted that out of here and made that a function up here. So that was part of what I wanted to show, is that you can write a function like this one right here that will take a producer and some other values, and then you can call producer.produce inside of there. And then down here inside of the code, we're going to call that function right here. This one, produce message, is going to be our function right here. So I probably need to work on this code just a little bit. So we have produce message, taking in a producer, an index, and a quote message. And then the key, let me clean that up a little bit, is going to be like that. And then for the key, as you can see, I'm just writing the JSON myself as a string right there. So I'm not using an encoder like I did previously. And then for the JSON value, I'm taking in, let's see, I have a quote as a quote message right here. Then for the JSON value, I'm just calling to.json on that one right there. Then when we call produce, like we did previously, we have the Kafka topic. The key is the JSON right there. The value is that JSON value right there. And I kind of want to rename this right here to be a bit more meaningful. So let me refactor that and rename. So I'm going to call that key. I guess that's a little awkward to call it key value, but that's what I'm going to go with right there, because I have JSON value. Actually, I don't like that name either. Let me call that one something different. And we could call that one quote value. We could call it message value or other names, but I'm going to go with key value and quote value. So we're calling produce, And as I noted before, this produces a single record and awaits broker acknowledgement. So it's going to send this record over to our Kafka server over here. We have the topic, the key value, the quote value. Both of those are strings like before. And then again, I'm tapping that and showing some logging here of what we created right there. So that is our produce message function. Now we come down to the run value. And just like before, we have ZIO.scoped. As I've mentioned in previous videos, scoped ensures that the finalizers are run as soon as this effect completes execution. Whether that's a success, failure, or interruption, the finalizers are always going to get called. And then we have what we had in the previous video. We have the producer, which is our ZIO Kafka producer. We call make. We give the settings, we call flat map. Again, if this was going to be multi-line code, you could have a for expression here, but because we're just having one line, we just call flat map. And then we have a producer value coming out of flat map. And then I mentioned way back in the earliest ZIO videos, you can think of flat map as meaning and then. So this is basically creating a producer instance, and then you want to run this code that's inside of the curly braces. I keep forgetting to mention that, so I finally mentioned that right there. Flat map is a nice way to extract the value out of a ZIO value here. So you could see we have the ZIO value here, and the value inside of that is a producer. So we call flat map right here, and that extracts that producer out of the ZIO value or out of the ZIO effect. So now we have a producer right here. And we're going to say produce all the quotes with a delay between them. And there was something I wanted to change here. So ZIO.foreach quotes zip with index. So quotes is that list of quotes right there. And we see that. So then I want to do a case quote index. So I have zip with index. So then produce message is our function. For some reason, my indentation is off here. We come back something like that. So then call produce message, producer index quote, small delay. I'm okay with all that. So what I wanted to do was, I've already got 18 keys in here, right? So I started with 1 and I've gone up to 18 right there. So in this code right here, just for what we're doing right here, I could say plus 18. That's going to start off at 0, so I should do plus 19. Okay, that's a little wonky, but I was just thinking about that when I was working over here. But I want to make sure that starts at 19. So in theory, this first message right here will be 19, and then this next one will be 20, because zip with index gives us the quote over here as the first value. You can see this is creating a tuple. That's what's coming out of this code right here, the for each code with that zip with index. We're getting a tuple, and the first value in the tuple, it's a 2-element tuple. The first value is a quote. The second value is going to be the index. The index starts at 0 for the first value. And then when there's a second value, that will be 1. When there's a third value, that will be 2. Of course, because this is 0 based. So then what I'm trying to do here is just add 19 to that so that this will start at number 19 over here. So if my logic is correct and produce message works as desired, it all looks good. And it is compiling, so I think we're ready to try to run that. So when this runs, we should get this message being inserted, and then what is that, 500 milliseconds later, this second message should be inserted. And in theory, you can just add up as many quotes as you want right inside of here, and then it will insert all of those. So let's go ahead and stop that right there. Now I'm going to run that, and when I start running that, I want to click over here to the Confluent side so we can see those being inserted. So run and click. And we should see 19 and 20 here eventually. And there they are. That was too fast for me. So we produced message 19 and we produced message 20. And indeed, we got 19 and 20 right here. All right, and just look at that. Make sure all that looks good. Enlightenment death has no relevance to one's state of being. And in real meditation, you forget the body. So that's all good right there. So that looks really good. So we got 19 and 20. And I just saw in my previous example here that I inserted this one as a string. And I did that in the previous video. So I'm going to have to remember to go back there and make a note about that. So I changed something in the code in the previous video at the last moment. And you can see what happens sometimes when I do that. So that one was inserted right there as a string. These are going to be integers here and here. Okay, for you it's just a couple seconds later, but for me it's a few minutes later. I was trying to figure out how to fix this problem. Part of what was going on, I was trying to figure out how this was even allowed, because with the Confluent Kafka product here, you actually have this thing called the data contract. And the data contract for a key, I set up this way. So I actually set up the ID, the type is specified as an integer, and it is required, as you see there, but I specifically set up that type to be an integer. So I was really surprised that inserting a string here was allowed. Okay, I did some research into this, and this behavior isn't a bug per se, but it's likely related to the loose type validation of using JSON for the data contract schema. Therefore, the short story, which I think I mentioned in other videos, is that I should have used Avro or protobuf to define the data contracts, because they're much more strict about types than JSON is. And had I done that, I should have gotten some type of serialization error at this point. But because I did use JSON, we don't see any errors, and I believe that's the cause of this issue right here. So that's a real key lesson. In the real world, make sure you use Avro or protobuf for defining your data contract schemas. So as a quick recap, we had all the inserts up here. We have object some name, extend ZIO app default. At the beginning here, we have all the Kafka and Confluent properties that we need. After that, this is our domain model right there, which is just the quote message. Then I added a JSON encoder for that message type. Then we created a list of sample data that we wanted to publish to Kafka, and indeed we did publish to Kafka. Then, compared to the previous video, what I did was I created this produce message function. So I took this code that was in the previous video right here, and I basically extracted that into this function right here. And the reason I did that is I wanted to show that you could write a function like this that would take a producer and then take other information, and then you could call producer.produce from inside of this function just like that. So it's just a reusable function. And the reason I wanted to have a reusable function was because I was creating this list of data right here. So that's why I wanted that function. And then once we had produce message, we come down here to the ZIO run value. We did the usual ZIO scoped right here. Then we have producer make. We use the settings right there. Then we have the producer. And then inside of the ZIO.foreach right here is where we call produce message. And as I mentioned earlier, ZIO.foreach, when you call it on quotes zip with index, what that does is it creates this 2-element tuple. So we have that right here. The first element in the tuple is the quote. The second element in the tuple is this index that's being generated. It's a 0-based index, so I added 19 to it so that the data would start with 19 right here. And of course, this is a little wonky in production. You don't want to do something like that, but that's how zip with index works. And then I called tap right here at the end, and I said all messages were sent to Kafka, and you could see that message right here, all messages sent to Kafka. So you could see, one thing I did not mention is that you could see the produce message line right here. You could see that was generated once on this line, then again on this line for the second data. So that was generated for 19. This was generated for 20. And what I wanted to show here is that this tap here is only called at the very end. So it says all messages were sent to Kafka right there. So this particular tap right here is only called after the ZIO.foreach finishes running. And then this is just called once, as you can see right there. So I didn't mention that earlier, and I wanted to make sure I mentioned that. So again, the purpose of this was to create a ZIO Kafka producer that produced multiple JSON messages into a Kafka topic, and that is what we have done. This is Alvin Alexander, and as always, I hope this has been helpful.